Welcome to the first module of our course on the fundamentals of building construction. In this module, we will walk through the foundational ideas that shape how buildings are conceived, planned, and constructed. Think of it as learning the language of construction, the terms, the concepts, the materials, and the early decisions that make a building possible. Building construction is one of humanity's oldest and most important skills. From the earliest shelters made of wood and mud to modern skyscrapers with steel and glass facades, construction has evolved dramatically. The field brings together art, science, and engineering. It combines the creativity of design with the precision of structural integrity and the practicality of materials and methods. In essence, building construction is the process of assembling materials in a systematic way to create a structure that serves a specific purpose, whether that purpose is to live, work, store, educate, heal, or produce. But it's not just about putting pieces together. It's about planning, choosing the right materials, and executing with safety, durability, and sustainability in mind. 2. The construction industry and the roles of professionals. The construction industry is a vast and interconnected network involving multiple disciplines. It includes everyone from architects and civil engineers to electricians, plumbers, project managers, and skilled laborers. Each has a unique role. Architects focus on the design, aesthetics, and functionality of the building. Civil/structural engineers ensure that the design can be safely constructed, taking into account loads, stresses, and stability. Quantity surveyors estimate costs, manage budgets, and ensure financial efficiency. Construction managers coordinate schedules, manage teams, and oversee day-to-day operations. Skilled tradespeople, carpenters, masons, welders, painters, and others who physically build the structure. Surveyors measure land and set out building lines with accuracy. One key principle in modern building construction is collaboration. A project is rarely the work of one professional, it's the combined effort of many, each contributing their expertise to achieve a shared goal. 3. Building classifications and functional requirements. Buildings can be classified in several ways, but two common approaches are by use and by construction type. By use, residential, commercial, industrial, institutional, and special use buildings. By construction type, load-bearing masonry, frame structures, prefabricated systems, etc. Regardless of type, all buildings must meet certain functional requirements. Strength and stability, able to withstand loads without collapse. Weather resistance, protection from rain, wind, sun, and temperature variations. Thermal comfort, adequate insulation for the climate. Acoustic performance, control of noise transmission. Fire safety, materials and designs that reduce fire risk and facilitate safe evacuation. Sustainability, energy efficiency, minimal waste, and environmental responsibility. 4. Site investigation and surveying. Before a single brick is laid, the land must be studied. Site investigation is the process of gathering information about the ground conditions, environmental factors, and existing structures. Key steps include topographic survey, mapping the physical features of the land. Soil investigation, testing soil strength, moisture content, and bearing capacity. Environmental assessment, identifying hazards like flood risk, contamination, or protected habitats. Surveying ensures that the building is positioned correctly, aligned with property boundaries, and built on a stable foundation. Errors in this phase can lead to costly problems later, such as uneven settling or legal disputes. 5. Site preparation and setting out. Once the site is approved, preparation begins. This includes clearing the site, removing vegetation, debris, and old structures. Leveling and grading, adjusting the ground to the required level. Marking boundaries, using stakes, strings, or markers to outline the building footprint. Access and storage planning, determining where construction materials will be stored and how machinery will move. Setting out is the precise marking of the building's position according to the design drawings. This process is critical for ensuring walls, columns, and foundations are placed exactly where they need to be. 6. Foundation systems. The foundation is arguably the most important part of any building. It transfers the weight of the structure to the ground in a way that prevents settlement or collapse. Types of foundations. Shallow foundations, spread footings, raft foundations. Used when soil is strong near the surface. Deep foundations, piles, casings. Used when good soil lies deep below the surface. Special foundations, designed for difficult soils, slopes, or waterlogged areas. A poorly designed or constructed foundation can cause cracks, uneven floors, and even total structural failure. That's why foundation design depends heavily on soil test and load calculations. 7. Building materials. Materials are the building blocks of construction, and choosing them wisely is essential. Common materials include stone, durable and strong, used for load-bearing walls, facades. Brick, traditional and versatile, available in various strengths and colors. Concrete, strong in compression, moldable into many shapes. Steel, excellent tensile strength, used for beams, columns, and reinforcement. Timber, lightweight, renewable, and easy to work with. Glass, used for aesthetics, daylighting, and sometimes structural roles. Composites, materials engineered for specific properties, like fiber-reinforced concrete. 8. Material properties and selection criteria. When choosing a material, consider strength, can it handle the required loads? Durability, how long will it last under environmental conditions? Workability, can it be shaped, cut, or joined easily? Cost, is it affordable for the project budget? Sustainability, is it eco-friendly or recyclable? 9. Mortars and bonding principles. Mortar is the binding material used in masonry to hold bricks or stones together. Its composition affects the strength and durability of the wall. Bonding patterns, like stretcher bond, English bond, or Flemish bond, are arrangements of bricks that improve stability and distribute loads evenly. 10. Damp-proofing and waterproofing principles. Moisture is one of the greatest enemies of a building. Damp-proof courses, DPC, and waterproof membranes prevent water from rising through walls or penetrating roofs and basements. DPC, usually a horizontal barrier of impervious material. Waterproofing, uses coatings, membranes, or sealants to stop water ingress. 11. Masonry construction techniques. Masonry involves building structures from individual units of brick, stone, or concrete blocks. Proper masonry ensures even joint thickness, correct alignment, adequate curing of mortar, structural bonding. 12. Early structural frameworks. Before advanced systems are added, the early framework of a building includes columns and beams for skeletal structures, load-bearing walls for traditional construction, temporary support or scaffolding for worker safety and access.